I think, is even more interesting and exciting than .NET, although not as practical yet. Firefox, Mozilla, the company got really fed up with all these memory corruption vulnerabilities, so they decided to invent a new language called Rust. And Rust is winning awards for the last several years as the program that programmers love. This is the language that most people would like to develop in, but almost nobody is allowed to develop in it because it's not really working very well yet. Rust code comes out big and slow. But this is the final word to end all these vulnerabilities we've been exploiting, as we're going to see. And you can install Rust on a Debian server. And so I've already done all the preparation here. All you do is install it. Now, so when you make a Hello World app, the way I found out how to make Rust go, you always have to put it in certain folders and then compile it. There might be a way to put it in just one file like C, but most modern programming languages are expecting to have a folder all full of many components that are compiled together. So for each new app, you have to make a folder and go in there and then create a Rust source file, which has a .rs extension. And then you have a function main and print line, Rust says hello. So it looks a whole lot like C. You have a main function and a sort of print. So that's this one. And when you're done compiling it, it'll just run in that folder. So here I can go into Hello World app. And in here I've got hello.rs. And so if I cat hello.rs, there it is, just those few lines, and I've compiled it. So if I run it, oops, come on. Okay, it just says hello. So that's the Hello World app, just to show that you've got Rust properly installed. Now we can have a little more fun. Let's go up here and go into this int app. Okay, and let's take a look at this one. And I think I'll make this a little bigger. All right, and fit it in the window a little better. All right, and check my limits. Okay, so now if I look at the source code for this one, okay, so here you use let to define a new variable. So I let I equals 1. Now if you don't tell it what type of variable to make, it will assume a 32-bit integer. Now I define I32, which is a signed 32-bit integer, and I set it equal to -5. Notice the colon. Colon equals mean I'm creating a new variable. Well, in this case, it's the type of variable that goes there. So here I settled for a default kind of variable. Here I specifically specified an I32, and now I'm going to print them. I goes here and J goes there. So this one, when I run it, the first one is 1, the next one is -5. So this is reasonable, and so again, just like C. So now if you do this, this program, this way, it will not run. You're going to have, if you run this code, you're going to see an error. And so let me show you that one. Let me modify my code to match that. Let me get rid of my Windows machine. I don't need it anymore. Okay, so if I do nano int.rs, okay, I'm going to put in that code and get rid of this code. All right, so now let's compile that with Rust C. I'm going to shrink this down. Okay, there we are. So if I compile it, now it complains. You cannot have a U32 equal to a negative number. And that's because U is unsigned. And if you go here, there's a tutorial about data types that will show you. So let's take a quick look at that. Here's the data types. When you define things, remember in C you have integer and character and pointer and other variables like that, variable types. You got variable types in Rust too. And they look like this. You have 8, 16, 32, 64, 128-bit. You got signed ones, which have an I, and unsigned integers that have a U. So you have to choose which integer you're going to have, and there are other types like float and such. But anyway, that's the point here. So here's the type of variables you can have. And so here I've taken an unsigned integer and set it to a negative value, and it tells you you can't do that. So this is a helpful error message, and you can fix the code. All right. Now we're going to add some numbers. In this one, make dir add app. So let's go here. This is what goes in add.rs. So, okay. Okay. There. So here I define a variable a equals 1, and then I do a equals a plus 1. Classic thing we've had in every, you should add 1 to that variable, and then I print it out. So let's try that. And so if I do the Rust C of add.rs, okay, now it tells me cannot assign twice to immutable variable. So you have to read this tutorial, and here you discover something a little bit mind-boggling. Rust variables are by default immutable. By default, variables are immutable. You can assign a value and you can never change that value. There are immutable variables in byte arrays in Python 3 also. At first it's kind of mind-boggling, but you get used to it. And so you have to tell Rust if you plan to let a variable change a value. Otherwise it will assume it's a static constant and can't change, and that's what happened here. You can't change it later because it's an immutable variable. So that's another fundamental Rust concept. But now we can get down to why Rust is cool. So here, right here is ovc.c. If I look at that one, this is a program that has an overflow in C. Now we're going to see how Rust fixes all the problems that we've been exploiting all semester. So here, I have an unsigned character x. It's an integer variable. I set it equal to 230, and now I'm going to just add 1 and add 2 and 3 to it, and let it keep getting bigger and bigger, starting at 230, and print out the answers. If I compile that in C and then run it, you can see it's 231. I add numbers, it gets bigger and bigger and bigger, and when it passes 255, it gets small again. Now think about, you might be used to this, but think about how cruel this is to the programmer. The developer is trying to do a job, they define a number, they add numbers to it, and now suddenly it gets small instead of big, and it didn't pop up a message during compilation, and it didn't pop up a message when running. This is why C really sucks, which is why there's so many defective programs in C that have these vulnerabilities. How is a developer supposed to understand this and avoid this? This is really cruel. Why would adding a number to it make it get smaller? That's a booby trap for your poor programmer to fall into. And that's what everything we've been doing in this whole semester is. C is full of like landmines, where you're just trying to do something perfectly sensible and it has a stupid result. And then some security engineer will say, what, are you stupid? You didn't see that was going to happen? Well, how are they supposed to see that's going to happen? They had 230 and they added stuff to it. It's kind of ridiculous for them to understand that your language is so cruel that when you add numbers to it, it gets small again. So Rust doesn't let that happen, which is why I say developers love Rust. So if I go to the Overflow app, and now I look at this, cat overflow .rs. Okay, here's the way to do the same thing in Rust. I now define a mutable variable so it can change, and I defined it as an unsigned 8-bit number. So this is the same thing as that char variable I made in C. So I started at 230, then I make a loop, and I just add 1. So let's see what happens when I run that in Rust. It adds up to 251, and when I try to add more to make this 8-bit variable over 255, then it stops with an error message. It says, no, you tried to add more that would make it bigger than you could store in that variable. Now this is acceptable, right? I'm able to control, if I'm really like worried about using memory or something, I might choose to use an 8-bit variable, but if I try to make it too big, instead of just giving me the wrong number, it stops and says, no, I can't do that addition. You'll violate the limits of what you defined here. This is much better for a developer. You find out there's a problem and you fix it instead of distributing code and it having some kind of overflow vulnerability. And this turns out to be true for all of them. Here's the string overflow, which I think I'll find in here. Yeah, so if I do this one, this is the classic string overflow that we've done many times. So I define a string that's got 5 bytes A's and 5 bytes here for B's, and then I print out the addresses where they're stored, and then I input a new value for string number 2, and this is in C. So if I run this one, which is st, okay, if I put in BBB, then string 1 contains A, this contains BB, string 1 contains A, the string 2 contains 3 B's now instead of 4. But if I put in more, like I'll put in 8 C's, then string 2 now contains 8 C's, and string 1 now contains 3 C's. So again, I invite you to consider how horrible this is to your developer. They wrote a program, they input a new value for string number 2, they took the value, it didn't complain when compiling, it didn't complain when running, and now a different string has changed its value. How am I supposed to get anything done in this language when it does insane things like that? This is why you get these vulnerabilities. It's not obvious at all that inputting string 2 is going to change string 1, and in a less cruel language it wouldn't happen, and that's what Rust does. So here's how you do it in Rust. You define these string variables mutable, and then you enter a new value for string 1, and if you run that, that's same, oops, all right, I got to move there. It's up here, STRA, okay. There it is. So new value for string 1, 1, 2, 3, 4, 5, 6, 7, 8, putting 8 C's, and what happens is string 1 now has the original 4 A's, and it added the 8 C's in the end, and string 2 did not change. So if I make it bigger, it just reallocates a bigger piece of space somewhere in memory and correctly adds the new data to that string, and it doesn't change any other string. It has no way to run out of one variable and leak into the next variable, which is, of course, what ought to happen. That's what would happen in Visual Basic or in Python or any other modern language. It's only C that is so cruel as to torture you by changing one variable, change another variable. And if you look at it in GDB, the debugger, you can see what it did. You can see where the strings are stored, and when you make the string too long, the address changes, and it does allocate a new block of memory somewhere else and point to it. So it's obviously going to use more memory and more processing time, but it's not going to have your developers go out of their mind, and it's not going to have so many vulnerabilities. But you can still do command injection. Remember this one here, command injection? Let's see. Let me figure out where I put that one. Yep, it's up here. So if I do cmdi.c, okay, here I'm going to create a command which is ping minus C1, and then I'm going to add the IP address that I read from them, and then I'm going to execute it as a system command. So this is the simple command injection. Do tools like Purify, I don't know. It's a good question. They might. And in practice, by the way, you know, Microsoft is talking about using Rust for part of the kernel, and other people are talking about using Rust but the problem is Rust is really slow. So the original plan was for Microsoft published their limited C libraries to try to remove the most dangerous things like string copy and getS, and force you to use string ncopy that only copies a certain number of things. That was their original plan, but even that didn't get rid of all the memory corruption vulnerabilities. That's why now they're talking about moving to Rust. But the alternative, of course, would be to just put more band-aids on C. And I haven't played with Purify, but I think I've heard of it, tools that try to remove the more dangerous C code. That's another way to go. And that might be the way to go, because the good thing about C is it is so efficient. C code is fast and small because it doesn't have any of these safety features, which are expensive. So putting more band-aids on your C might be the way to really make a nice fast operating system, but it's riskier. Switching to Rust is really hitting it with a big hammer, excepting making your code much bigger and slower to make it much safer. Anyway, so here I got a command injection in C. So if I do cm, oops, got to hit this, cm, yeah, okay. And then I put in an IP address like 8.8.8.8, it pings it, but I can put in 8.8.8.8 semicolon ID. And then it will do the ping, and then it will execute the ID command. I've got a command injection vulnerability because it's using my data. And it turns out, as you might imagine, that you can do this in Rust too. You can use cargo, and then you can write code that will do the same thing. It will run the command ping plus the IP from the user. But if you do that, it will in fact it will have the same vulnerability. Your Rust code will have the same issue. You can do 8.8.8 date and it will run it because, of course, you have done the same thing. It cannot save you from this. When you take one language, write a line of code, interpret it in another language, Rust will just do the same thing. So it's not like it solves every possible problem, but it does solve these memory corruption problems that come from these awful things like an integer you define in C is not really an integer. It's just a byte that can overrun, and a string is not really a string. It's just a group of bytes that can overrun, and that's the problem. Rust creates abstract objects which are much closer to what a human really expects an integer and a string to be, so that when you manipulate them in obvious ways, they do not have appalling, disastrous, wrong results. So this is a good thing to know about, although I think I mentioned not enormously practical yet. People are trying to move to Rust and exploring it, but they're not moving to Rust in any large numbers yet. And I made another one here where you can try even a few more Rust things like dangling pointers and memory leaks. You can make them in C and then see to what extent they're mitigated in Rust. But the whole point of Rust is to remove most of the vulnerabilities, and many people are much happier with it. So as development proceeds, I know Mozilla quit it because I think Mozilla is pretty much going broke. Somebody else bought it, like Oracle or Microsoft or somebody. Somebody else became the maintainer of Rust. So Rust is still under development. And it remains to be seen how many people will really find that they can get the job done in Rust. But it's real fashionable. So I thought you ought to check it out and become aware of it.